Ladies and gentlemen, this video mainly addresses the non-renewable and renewable components which are connected to microgrids. In this video, we briefly survey distributed generators and review their main characteristics, advantages and disadvantages. The main learning objective will fall under three main points. First, what are the non-renewable and renewable distributed generators technologies which are connected to a microgrid? Second, what are the main characteristics of these units? Third, what are the advantages and disadvantages of these non-renewable and renewable generators? We now start to first introduce three widely used generators based on non-renewable resources. The reciprocating engine, which utilizes resources like diesel and gas, is one of the most important developments and inventions in the 19th century. The size of this engine could vary from the very low to high values, for instance from 3 kilowatt to 6 megawatt. Secondly, gas turbine is one of the most advanced and mature technologies. The size of a gas turbine could reach up to the few megawatts. The third generator based on non-renewables is a microturbine, which is an emerging and promising technology which utilizes non-renewable resources, bio or natural gas. Note that the microturbine is basically a scaled-down gas turbine that is, however, operated at much higher rotating speeds, around 10 times higher than a normal turbine, for instance at 500,000 rotations per minute. Typically, the microturbine consists of three parts: the turbine, radial flow compressor and combustor. The size of microturbine could vary from low to high values, for instance from 30 kilowatt to 1 megawatt. In this slide, we compare the three previously introduced technologies in terms of primary source, output voltage, installed capacity, and electrical efficiency. Diesel and gas are the primary sources of reciprocating and gas engines. All these three generators are operated with the output of the voltage AC and could reach the installed capacity of 30 megawatt. Their electrical efficiency, which depends on the operating point, has a value approximately between 20 and 35%. Note that if gas turbines are used for combined heat and power applications, then they may reach up to 80% efficiency. The advantages of reciprocating engine are the low cost and flexible control over the input mechanical power. The advantage of gas turbine is that, as mentioned, they could reach high efficiencies in combined heat power applications and become more cost efficient. They have higher ramp-up capabilities, which makes them crucial for the black start application and covering the peak load. If the gas is used as the primary source, then they become environmentally friendly. The advantage of microturbines is that they're small size and low weight. They have a straightforward startup and shutdown process, as well as low maintenance costs. The disadvantage of reciprocating engines is that they are environmentally unfriendly due to the emissions. The gas turbines are typically too large for small consumers. The microturbine is still under development and relatively expensive. They are also environmentally unfriendly due to the emissions. On the other side, we can have a microgrid distributed generators based on sources from renewable energies, namely wind generator, solar photovoltaics, biomass power plant, hydro units, geothermal, ocean energy, and solar thermal plant. In this slide, we review the main characteristics of these renewable-based generators in terms of primary source, output voltage, installed capacity, and electrical efficiency. The primary source of most of these technologies are known. Note that geothermal and solar thermal plants use the hot water to generate the electricity. The output voltage of all these technologies, except the solar photovoltaics, is AC. With respect to the installed capacity, over the last year, large-scale wind turbines up to 9 megawatt have been installed, and upscaling is the way to reduce the cost. Also, the largest installed capacity of hydro units is now over 1 gigawatt. Both wind and solar photovoltaics have the theoretical efficiency between 40 and 60%, depending on both technology and operating point. Practical efficiency is different. For example, for commercially available solar cells, it is around 20%. On the other side, geothermal and solar thermal units have the relatively low efficiency, for instance between 10 and 20%. The important advantage of wind and solar is that they are abundant in many locations. Also, wind turbines are a mature technology where they can generate electricity through the whole day. Solar photovoltaics units have a very flexible installed capacity and are suitable for many applications like off-grid and pumping. To mention a few advantages of other renewable-based generator technology, they are also environmentally friendly and have low or zero running cost. Biomass power plants are efficient as they use alcohols and other fuels produced by biomass. Hydro units are useful for providing peak power and spinning reserve. The disadvantages of wind turbines are that they are still expensive and they introduce a high level of stochasticity into the electrical grids. Photovoltaic solar units usually need storage mechanisms, which we address later in this week. To mention a few disadvantages of other renewable-based technologies, for example hydro units, they are mostly expensive and they, except ocean energy, have low energy densities. Well, in this video we summarize the characteristics, advantages and disadvantages in terms of primary source, output voltage, installed capacity and electrical efficiency for distributed generator units based on non- and renewable energies, such as reciprocating engine, gas turbine and microturbine, as well as renewable energies, wind turbine, solar photovoltaics, biomass power plant, hydro, geothermal, ocean energy and solar thermal plant. In the next video, we mainly address advantages and disadvantages of various storage technologies.